Hi guys, so today we'll be solving this problem called global and local inversion. Let's solve it. We have some permutation A of 0, 1, n minus 1, where n is the length of A. The number of global inversion is the number of I less than j, 0 is less than equal to I is less than j is less than n, and A of I is greater than A of j. Number of local inversion is the number of I with 0 less than equal to I less than n, and A of I is greater than A of I plus 1. Return true if the number of global inversion is equal to the local inversion. So basically in this array, if we see 1 is greater than 0, therefore we have one local inversion. Then 1, after that we don't think we have any other local inversion. Similarly, when we put a loop for global inversion, we get 1 is greater than 0. So we have one global inversion as well. Similarly, in this, 1 greater than 2 is not a is not a local inversion. 1 greater than 0 is a global inversion. So we have one global inversion till now and 0 local inversion. Similarly, 2 on the second current element will go to 2 and 0. 2 is greater than 0, therefore we have two global inversion. And if we see A of I is greater than A of I plus 1, therefore we have one local inversion. So what we can do is, uh, first we can basically uh, do the extremely simple brute force approach, which will be to uh, scan the array and put the condition as A of I is greater than A of I plus 1, and we count the number of local inversions first. Then we put another loop, uh, which will be O of n square, as it will pass from I and j. So A of I will be greater than A of j. If that condition is satisfied, then we count the number of global inversion. Then we see if local inversion and global inversion is equal to each other, then we return true, otherwise we return false. But we need to solve this. The time limit for this problem has been reduced. They have mentioned it here. We need to solve this problem in O of n. So what we'll do is that basically we'll be going from the last element. We'll be checking from the last element, and if the element which is I minus 2, if the element which is I minus 2 is greater than the current element, so we return false. Otherwise, we check, we do an exhaustive search like this uh, throughout the the array, and we also maintain a minimum so far of the elements. So whatever that is, we'll basically check if it is greater than the minimum so far. If it is, then we'll basically return false. If I minus 2 is greater than this, we'll return false. So let's try to solve this. So we'll create n is equal to a dot size int floor is equal to n, and now we'll run a for loop. I is equal to n minus 1 starting from the last element, and I is greater than equal to 2 because we have to go till I minus 2, so all the element before 2 will already be traversed. So I minus minus. Now we'll maintain the floor. Floor is equal to minimum of floor minus a comma a of I. So whichever is minimum between both of these, we'll return that. Basically, we'll take it as minimum so far, and then we have uh, we have to check if I minus 2 is greater than floor. If that condition is satisfied, then we return false. Otherwise, we do an exhaustive search throughout the array and we return true. Let's run the code if everything is working fine. Yeah, that works. All right. So I hope you guys understood the problem for today. Thank you.